Welcome to episode 7 of the Enrichment series, and in this take we're going to be doing proofs of log properties. So here is a little summary of what those properties are, if I can center it. And you are welcome to take a screenshot of this if you want to. These are all the major rules that you would do in the pre-cal class, so I'm going to go through this really quickly and then we're going to get on to the proofs. The composition rules have to do with the fact that log functions and exponential functions are inverses of each other. So if I have log base b of b to the power of k, basically what that says is everything's going to cancel and you're going to be left with that variable k. Same goes as if you have a base of b, and in the exponent you have log base b of k. The b and the log base b, that's just going to cancel and you'll be left with k. There's an example under there. Power rule says that no matter what the base is, let's say that they're not the same and you have b and m, and you have that exponent there, you can actually move it to the front. Quotient rule, if you have two things that are divided with a logarithm, you can split that up into two logarithms and subtract them. I don't know why I just paused there. And so product rule, kind of the opposite. If you have two things that are multiplied in the logarithm, you can split them into two and add them. And examples under every one of these. Finally, the identity rule is kind of just like logical, but basically if you have log base b of b, that equals 1, which makes sense because what exponent would have given you that answer, right? If you have 2 to the power of what equals 2, that's going to be 1. So that is known as the identity rule. And for things like the power rule, the quotient, the product rule, you can go back and forth. So if you have the subtraction, for example, right here, log base b of m minus log base b of n, you can combine that and do the division. So you can go either way. Okay, leave that there if you want a screenshot. Yay. All right, I'm moving on. So what is a proof? Proof is a series of mathematical statements that follow logically from one point to another. And you have three different parts. There's a beginning, which are the things that were given, the things that we're assuming to be true, and that would include any definitions. The middle is going to be your statements, and the end is what we are trying to prove. So typically, in whatever prompt, you'll be given the beginning, so, the givens, that's weird to say, and then the end, or what you're trying to get to. And what you need to figure out is the middle and how things connect in order to get to that ending. So pretty cool. All right, let's start with the power rule. We're going to prove that log base b of x to the power of k is the same as if we moved that k out in front as a multiplier. And we're given that m equals log base b of x. All right, so here's how I would approach this. You want to prove this right here equals something, log base b of x to the k. So if we're given that m equals log base b of x, we really want that k up there, because then we want to see, well, what does that equal? Does it equal what we want it to equal? So what we want to do here, we can't just raise both sides to k because that's not going to put the exponent on the x itself. We're going to isolate x and do whatever we need to do to get it into this form right here. And then we'll see what that equals. So kind of just thinking about, how are we going to get to that ending? All right, starting with number 1, let's go ahead and change it into an exponential. So that's going to just be the definition of a logarithm. This is known as a 2-column proof, where you do the thing on the left side, and the right side is a justification. So let's change this to log form, exponential form. So it's going to be b to the power of m, which equals x. So you should know how to switch between the two. And the second step here is we want to raise x to the power of k. So that way we can take the logarithm after that. So b to the m equals x. And we're going to raise both sides to the power of k. Now, the power of a power rule says that if we raise an exponent to a power, we multiply the exponents. So x to the k is going to equal b to the m times k. All right. Step 3, we want to take the log base b of both sides. So we can get that left side of the end right there. So we're going to do log base b of x to the k equals log base b of b to the mk. Sounds like a song or something. B to the m to the k. Okay, bad joke. And you should be at the point where if you see the log base b of b, log base 2 of 2, log base 5 of 5, you know to cancel that and bring the exponent down. So we'll rewrite this as log base b of x to the k equals mk. Now, finally, we don't want to leave it in terms of m because they gave us a definition of m. So we want to replace it with the definition they gave us, which was log base b of x. So let's go ahead and replace m with that. So log base b of x to the k is going to equal k times m was log base b of x. And that is exactly what we were looking for, that we can move the exponent out in front there. All right, let's move on to the next one. I'm going through these really quickly. I have 2 more to do, including this one. Okay, so this is product rule. If we have log base b of x times y, we can separate that into 2 logarithms and add them. And they gave us definitions of m and n. So we're going to start it the same way by isolating x and y so that we can get it to look like this side right here, and then see whatever the right side looks like. So let's start by changing these into the form that we want. The arrow means like if then. So if this is true, then this is true. Just so you know. So b to the m is going to equal x. And then we have to do the same thing for n now, because we've added that into the equation. Log base b of y. So that is the same as b to the power of y, b to the power of n, and that's going to equal y. All right. And so now we want to multiply x and y because that's what's in our argument right there. So x times y, well, we see what those are equal to in terms of b and m. So we're going to multiply those as well. Now the product rule of exponents on the right there says that if we have the same base and they're multiplied, then we can add the exponents. So that's going to equal b to the m plus n. Okay, and the next thing we want to do, if we're looking at our ending here, take log base b of both sides. Let me scroll down. So log base b of x to the y, x times y, is going to equal log base b of the other side, which we said was b to the m plus n. And whenever you see that log base b of b, you're immediately like, no, you can't exist. You get rid of it. And that is the composition of inverses rule. I kind of just made that up. I don't know if that's actually what you call it, but that is the way I think of it. And then we can bring that exponent down. Okay, the final thing we need to do is replace m and n with the definitions that we were given in the beginning. So log base b of x times y equals m plus n. Log base b of x times y, and m was log base b of x. So let's go ahead and replace that. Plus, and then n was the same thing but with y. So log base b of y. And that right there checks out with what we were trying to get in the beginning. All right. For the quotient rule, feel free to pause and try it yourself because it's very similar to the last one. But yeah, I'm going to go ahead and get started. So we are going to do the exact same beginning and change what we're given into exponential form. So let me back up for a second. The quotient rule is if x and y are divided, then you subtract the separate logarithms. So a little bit different. But anyways, let's go ahead and change these into exponential form. Again, the reason we do this is because we want to isolate the variables and then manipulate them to get them to look like our ending right here. Okay, I keep doing that. It's b to the n, and that's going to equal y. Okay, so now, as you probably figured, instead of multiplying x and y, we're going to divide them. And then so we're going to use the definitions we found in part 1 and divide those as well. So x is b to the m, y is b to the n, so we're dividing them now. Well, what does that equal? We're able to do the division rule of exponents, which says that if they have the same base and you're dividing, then you're going to subtract the exponents. So this is really b to the m minus n. Step 3, again, we're just going to take the log of both sides, log base b, and that's going to get it looking like what we want it to look like. You should see that log base b of b and immediately cancel that out. All right, and that is going to equal m minus n when we bring down the exponent. Here's the last step. We just have to substitute the definitions for m and n. So log base b of x over y equals log base b of x, that's what m was, minus log base b of y, that's what n was. Extend the page there. Okay, and then that checks out with what we were trying to get. Boom. Yeah, so that's a 2-column proof. We did 3 of those, and I hope that was helpful.